Hey guys, I just want to go through some of these function families with you. So this is in your notes. In this chapter, in chapter 5, we're going to talk all about functions. So lots of graphing, lots of equations, lots of graphing. There's 9 function families we're going to talk about. And all 9 are listed here in your notes. And I was just going to kind of talk through briefly about the differences between all of them and then what to look for. So I guess we'll start here at the top. This is a linear function. Now with all of these functions, on the left-hand side over here is where I describe the different kinds of equations you might see. And then this part right here tells you exactly what the kind of the part that you can see that kind of separates its kind of function from the rest of the functions. So like for a linear function, it's x to the first power, kind of like mx plus b. And you might see this f of x here as we go through. So f of x and g of x, they're just different names, but they just mean y. So on the right-hand side over here is where I talk about what the graphs look like. And a linear function obviously looks like a line. It's pretty easy to determine. But for each one of these, I tell you what the graph is going to kind of look like. Now, it could be upside down. It could be moved around the graph a little bit. But this, in general, is what the graph's going to look like. So for absolute value, you're looking at an absolute value symbol. So the 2 little lines right there, just like this equation. And the graph looks like a V. And the easy way to remember that is absolute value V. The next function is quadratic. That's x squared, so x to the second power. So that means the highest exponent of x in the equation is 2, so x squared. And then the graph looks like a U. Again, it could be upside down. It could be right side up like this. Technically, that's called a parabola, but I'll just call it a U shape. The next function is a square root function. That graph or that equation is super easy to tell because it's a square root symbol. And it looks like a U on its side cut in half. So you can kind of see it here. Now it can also go down this way like that and open that way, or it can open this way. But it's a U on its side cut in half. The next function is a cube root function. And it's just like a square root function, except the index on the square root is a 2. The index on a cube root is a 3. And the graph looks like an S or a backwards S. Rational function. This is x in the denominator. It's not just that it's a fraction, because I could have a fraction like x over 2, and that's actually a linear function. But the important part here is that x is in the denominator. And it looks like 2 exponential graphs on the same graph. And we'll see here in a second what an exponential graph is, but it looks kind of like a slide. So it's like 2 slides on the graph together. Exponential functions look like 1 slide, and I say it looks like a quarter pipe because if you take a circle, which is like if you look down a pipe, it looks like a circle. If you cut a quarter out of it, then it looks like a quarter pipe. It's like a slide. And the equation is x is in the exponent. So you can see right there, b to the x power. It's not that it has an exponent, it's what's in the exponent that's important. It's x is in the exponent. Logarithmic, we're not going to do much with. The equation is easy to see. It has the letters log or log. It's a short version of logarithmic. The graph looks kind of like an exponential function, but I will always give you the equation. We're not going to do much with this, so I wouldn't worry too much about it. And then the last one here is polynomial. Polynomial functions are anything with x to the third or higher. So x to the third, x to the fourth, x to the fifth, and higher. X squared is quadratic. X to the third or higher is polynomial. Now, the graphs can look somewhat different for polynomial functions. The graphs for an odd exponent kind of look like this, where it's an S kind of standing up on its side. And the ones with a even exponent actually kind of look like quadratic. They're kind of like a U-shaped. So if I just gave you that graph without telling you the equation, you might say it's quadratic. So I will never give you a polynomial graph without giving you the equation as